Welcome to Worldwide News. Please subscribe and hit the bell icon for more breaking update. In the silent expanse of our solar system, where planets, moons, and asteroids drift through the endless night, a new and unexpected phenomenon is capturing the attention of astronomers everywhere. For centuries, we've watched comets streak across the sky, their icy tails glowing as they're shaped and sculpted by the relentless force of the solar wind. But now, something extraordinary is happening. Something that challenges our most basic assumptions about how the universe works. A new cosmic mystery is unfolding before our eyes, one that could rewrite the textbooks and force us to reconsider what we know about the forces at play in our solar system. Astronomers have turned their telescopes and instruments toward a peculiar visitor, Comet Atlas. Comet Atlas is doing the unthinkable, defying expectations and rewriting the rules. Instead of being shaped by the solar wind, as every comet before it, Atlas appears to be actively distorting the very wind that should be controlling it. Its magnetic field and outgassing are so intense that the solar wind bends and twists around it, creating a spectacle never before observed. Rather than acting as a passive weather vane, simply pointing away from the sun, Atlas seems to be pushing back, bending the solar wind around itself, almost as if it's carving its own path through the solar system. This behavior is so unexpected that it's challenging everything we thought we knew about the delicate dance between comets and the solar wind. The discovery has sent shockwaves through the astronomical community. Scientists are poring over data, re-examining old theories, and debating what this could mean for our understanding of space weather. If a single comet can have such a dramatic effect, what else might be possible out there in the vastness of space? If a relatively small comet like Atlas can influence the powerful solar wind so dramatically, it raises profound questions. Could other small objects, asteroids, or even interstellar visitors also be shaping their environments in ways we've never imagined? What hidden forces might be at work, quietly rewriting the rules of our solar system? The Atlas mystery is a wake-up call for scientists and stargazers alike. It's a vivid reminder that the universe is still full of surprises, and that our understanding, no matter how advanced, is always evolving. Each new discovery opens the door to more questions, more mysteries, and more one. So the quest to solve this puzzle is just beginning. As astronomers gather more data and develop new theories, the story of Comet Atlas promises to reshape our view of the dynamic, ever-changing space around us, and remind us that the cosmos is far more complex and fascinating than we ever dreamed. To grasp the Atlas mystery, we need to understand the solar wind. The sun constantly emits a stream of charged particles, plasma, blasting through the solar system at over 1 million miles per hour. This solar wind shapes the heliosphere, bathing every planet, asteroid, and comet in its flow. Sometimes the sun unleashes violent storms called coronal mass ejections, or CMEs, which can disrupt satellites and power grids on Earth. Our models have always assumed the solar wind dominates, pushing smaller objects like comets around. But Atlas is challenging this core principle, suggesting the solar wind's behavior is more complex than we realized. Understanding these interactions is crucial for predicting space weather and protecting our technology. The Atlas anomaly forces us to reconsider the forces shaping our cosmic neighborhood. Comets are ancient, icy relics from the birth of the solar system, preserved in the Oort cloud and Kuiper belt. When a comet nears the sun, its ices vaporize, creating a glowing coma and spectacular tails. The ion tail, always pointing away from the sun, acts as a natural probe of the solar wind. For centuries, comets were seen as omens, but science revealed them as predictable, fascinating objects. Modern missions like Rosetta have landed on comets, uncovering their complex chemistry and geology. Through it all, we believed comets were passive, shaped by the sun's overwhelming force. Their tails were thought to be simple reactions to solar wind and sunlight. Atlas is now rewriting that story. We've long known the solar wind can dramatically affect comets, sometimes even tearing off their tails during powerful solar storms. In 2002, a CME slammed into Comet Ikeya-Jong, snapping its ion tail, a vivid demonstration of the sun's power. These disconnection events turned comets into natural laboratories for studying solar storms. By tracking these disruptions, scientists could measure the speed and structure of solar wind far from Earth. This cemented the idea that the sun is the hammer, and the comet is the anvil. For years, this one-way relationship seemed unbreakable, but the Atlas observations have upended this model. Suddenly, the comet isn't just a victim, it's an active player. That's what makes the Atlas anomaly so electrifying for science. The Atlas mystery began with routine observations, until astronomers noticed something strange. Instead of the solar wind battering the comet, the region ahead of Atlas showed a massive disturbance. The solar wind slowed and deflected millions of miles before reaching the comet, as if Atlas projected an invisible shield. This effect was far larger than any model predicted for such a small object. Some theorized extreme outgassing, but even that couldn't explain the scale. The comet seemed to be a major obstacle, not just a passive traveler. This forces us to rethink plasma physics and the way comets interact with the solar wind. Atlas has become a cosmic agent, not just a bystander. The Atlas anomaly has energized scientists worldwide, sparking a wave of excitement and curiosity across the global scientific community. From seasoned astrophysicists to young graduate students, researchers everywhere are captivated by the mystery, eager to unravel what lies behind this unexpected cosmic event. Dr. Michael Comby, a leading comet expert, points out that the scale and nature of the disturbance caused by Atlas simply aren't predicted by our current understanding of physics. The anomaly challenges the very models that have guided comet science for decades, leaving even the most experienced researchers puzzled and intrigued. In response, new theories are rapidly emerging. Some scientists speculate that negative ions, rarely considered in cometary physics, could be playing a much larger role than previously thought. Others are exploring the possibility that complex wave-particle interactions, perhaps triggered by the comet's unique composition or trajectory, are amplifying its influence in ways we've never observed before. The phenomenon is fleeting, making it a race against time. Researchers are working around the clock, coordinating efforts to gather as much data as possible from both space-based and ground-based observatories. Every observation, every measurement, could hold a crucial clue. Each instrument offers a unique piece of the puzzle, whether it's analyzing the gas composition of the comet's coma, detecting subtle shifts in magnetic fields, or charting the velocity of the solar wind as it interacts with Atlas. Together, these data streams are helping scientists build a more complete picture of the event. This unprecedented level of global collaboration is science at its best, open, dynamic, and driven by a shared sense of wonder. Teams from different countries and disciplines are sharing findings in real time, challenging each other's assumptions and pushing the boundaries of what we know. The Atlas mystery isn't a failure of existing theory, but rather an extraordinary opportunity for discovery. It's a reminder that science thrives on the unknown, and that every anomaly is a chance to learn something new about the universe. The anomaly acts as a signpost, pointing us toward new physics and a deeper, more nuanced understanding of our solar system. It invites us to question, to innovate, and to imagine possibilities that once seemed out of reach. Whatever the answer turns out to be, one thing is certain: we'll emerge from this investigation with a richer, more profound view of the cosmos and our place within it. The universe has handed us a puzzle, one that challenges our intellect and our imagination. And as always, the scientific community is determined to solve it no matter how complex or mysterious it may be. Solving the Atlas mystery isn't just for professionals. Amateur astronomers play a vital role. Their round-the-clock observations provide crucial data on the comet's brightness and behavior. In past discoveries, amateurs helped pinpoint the exact moments of dramatic comet events. Today, digital technology and global networks make citizen science more powerful than ever. This partnership democratizes discovery, turning astronomy into a shared adventure. The next breakthrough could come from anyone with a telescope and curiosity. The Atlas anomaly isn't just a cosmic curiosity, it has real-world consequences. Our satellites, power grids, and communications depend on accurate space weather forecasts. If comets can distort the solar wind, our models, and our defenses, are incomplete. A surprise solar storm could disrupt satellites or trigger massive blackouts, as happened in Quebec in 1989. As we plan missions to the Moon and Mars, understanding these risks is critical for astronaut safety. The Atlas mystery exposes gaps in our knowledge, pushing us to build better models. It's a call to action for scientists, engineers, and policymakers alike. The universe is more unpredictable than we thought. Solving this puzzle is essential for protecting our technology and our future in space. Comet Atlas has transformed from a familiar celestial visitor into a profound enigma, upending decades of scientific theory and sparking a wave of curiosity across the astronomical community. What once seemed predictable has now become a puzzle, challenging our understanding of how comets interact with the forces of our solar system. The relationship between comets and the solar wind is no longer a simple, one-way interaction. Instead, it's a complex and dynamic dance, with each influencing the other in ways we're only beginning to grasp. The solar wind, a stream of charged particles from the sun, shapes and sculpts the comet's tail, but new evidence suggests comets may also affect the solar wind in return, creating a fascinating feedback loop. To unravel this mystery, scientists will need to launch new missions, gather more detailed data, and approach the problem with fresh, creative thinking. The tools of modern astronomy, spacecraft, telescopes, and computer models will all play a role in piecing together this cosmic puzzle. Every new comet that streaks across our skies is now seen as a potential laboratory for discovery, offering unique clues about the forces at play in our solar system. Each observation brings us closer to understanding the intricate connections between the sun, comets, and the vast space between. In this quest, citizen astronomers are more important than ever. With modern technology, anyone with a telescope and curiosity can contribute valuable observations. From backyard astronomers to students and hobbyists, the search for answers is open to all, and every data point helps build a clearer picture of these cosmic phenomena. The story of Atlas is a vivid example of science in action: observation, surprise, and the drive to understand the unknown. Each unexpected finding pushes us to ask new questions and refine our theories. Behind every discovery is a relentless pursuit of answers, fueled by curiosity and collaboration. Teams of scientists around the world are working together, sharing data and ideas, determined to unlock the secrets hidden in the stars. The cosmos doesn't owe us easy explanations. Its mysteries are vast and often elusive, but it's precisely these challenges that inspire us to keep searching, to keep questioning, and to never stop exploring. The unknown is what drives us forward, pushing the boundaries of what we know and daring us to imagine what's possible. Each new mission, each new observation brings us a step closer to understanding our place in the universe. As we probe deeper into the secrets of Atlas and the ever-changing solar wind, we're not just learning about comets, we're uncovering the fundamental processes that shape our solar system and, ultimately, our own existence. With every discovery, we gain a new perspective on our place in the cosmos, so keep looking up, because the universe is full of surprises, and the next great breakthrough could come from anyone, anywhere. Whether you're a seasoned scientist or a curious observer, your passion and curiosity could lead to the next big discovery. The universe is waiting for new explorers. The universe's greatest secrets are still waiting to be revealed, and together, we can uncover them, one discovery at a time.